Hello everyone, welcome to our channel Off Campus. In this video we are going to see in differential equation. Previously we have seen many problems under differential equation. This is a continuation of our previous video. In this video also we are going to see what is particular integral and complementary function, solve few examples on that solution of differential equations. So kindly subscribe our channel Off Campus and then click on the bell icon, then only you will receive notification whenever we upload videos. Okay, let's go into the video. The first question is that this is the first problem, particular integral of the given function. We need to find out the particular integral for the given differential equation. What is given? d cube minus 1 into y equal to x sin x. So first we need to find out the particular integral. It is nothing but x sin x right hand side divided by that given function d cube minus 1. Just write d cube minus 1. Then what is the next step? Whenever it is comes multiplied with x sin s, we have one formula. What is that? How to proceed that? We'll see. What is f of d first? D cube minus 1. So 1 by f of d x v. So if it is in the form of 1 by f of d into x v multiplied with some function x, we need to follow this formula. Okay, 1 by f of d is nothing but d cube minus 1 x into sin s. Here what is v? V is nothing but sin s. V equal to sin x. So 1 by f of d x v. How to find out the particular integral is nothing but x into, take x outside, 1 by f of d into v minus f dash of d divided by f of d the whole squared into v. Okay, so this is the formula. We are going to apply this formula for this problem. Okay, what is v here? V is equal to sin x. Okay, v equal to sin x. Just substitute all values in that formula, then we can find out the particular integral. Okay, in that equation. So f dash of d is nothing but differentiation of f of d divided by f of d the whole square. We'll see how to solve this. Okay, x into 1 by f of d nothing but d cube minus 1 into v is nothing but sin x minus what is f dash of d? F dash of d is nothing but this one, differentiation 3d squared. So 3 f dash of d is equal to 3d squared. 1 is a constant, so we will get 0. So just 3d squared. So substitute 3d squared divided by f of d the whole square. D cube minus 1 the whole squared into v. V equal to sin x. Okay. Now we are going to simplify this. See. What is the next step? X into, so we can rearrange whenever sine function come, we should replace for d squared equal to minus alpha squared. Here d squared is not there, so we can write it as x into, here d cube na, d cube we can rearrange as d into d squared. Okay, can we write like this? D into d squared minus 1. Okay, why? Because whenever sine function come, we should replace for d squared equal to minus alpha squared. Here also the same thing, in the denominator d cube now we can write it as d into d squared minus 1 the whole squared into sin x. Now we can replace for d squared equal to minus alpha squared. So d squared equal to sin alpha x. Here in place of alpha 1 here, minus alpha squared. Alpha is nothing but 1. Okay, in place of alpha 1 here, so minus 1 square, so minus 1. The square is only for the constant, not for the negative value, so we should keep the negative sign as it is. So d squared equal to minus 1. Just substitute in that equation. In place of d square we are going to substitute by minus 1. So d, okay, d into minus 1 minus d minus 1 into sin x. Again in numerator also 1d. So 3 into minus 1. So here minus d minus 1 the whole square into sin x. So numerator part minus 3. So take minus sign outside and we'll go to the numerator minus x sin x divided by d plus 1. Okay, minus will be go to the numerator. Minus into minus plus, here minus, it is not minus 1, it is 3. In above 3 na. So it is 3 sin x minus into minus plus sin x divided by d plus 1 the whole square. So when we take minus outside and then square, we will get negative sign will get squared as positive sign. So here see, there is 3 sin x divided by d plus 1 the whole squared. Okay, now what is the next step? So x sin x. So page is insufficient, we will take some other paper to solve this. See, we will take some other paper to solve this due to insufficient space. So minus x sin x divided by d plus 1 plus into multiply by conjugate d minus 1 and to d minus 1 in the numerator and denominator as well. Here d plus 1 the whole square, we can expand a plus b the whole square formula. D squared plus 2d plus 1. Okay, then numerator multiply by d minus 1. So minus x into d minus 1 into sin x divided by a plus b into a minus b. So d squared minus 1. In here 3 sin x divided by d squared plus 2d plus 1. Then what is the next step? We should replace for d squared equal to minus alpha squared again. So d squared equal to minus alpha squared equal to minus 1. Alpha is nothing but 1 here, sin x, coefficient of x. So d squared equal to minus 1. Just substitute minus 1 in place of d squared. Okay, in numerator multiply by d minus 1. So minus x into d nothing but d by dx, differentiation of sin x, we will get cos x, right? Minus x cos x minus sin x divided by d squared in place of minus 1. When we substituting minus 1 minus 2, again 3 sin x d squared equal to minus alpha squared. So minus 1 plus 1, minus 1 plus 1 get cancelled, right? Here in denominator we will get 2d. So what is that? Take minus sign outside. Here in numerator I did one mistake, right? Numerator minus x into minus x cos x plus sin x by 2, 3 by 2. I will tell this what is the mistake. 1 by d denotes the integration. Okay, whenever d differentiation d by dy, if it is in the denominator 2d, it is represents integration. So integration of sin x minus cos x, that is 3 by 2 into minus cos x. So here I done one mistake now. So x cos x minus x into differentiation of sin x cos x, again minus into minus 1 plus, right, minus x into minus x outside. So I will take minus x outside. So what we will get? So the sign change will Right. So nothing but x cos x minus sin x divided by 2. That is what I did a mistake, right? Now previous one, C equal to x by 2 minus x differentiation of cos sin x cos x plus sin x. It is not plus sin x, x cos x minus sin x by 2. Minus sign, right? X by 2 will be in the outside. X by 2 is common for both. So, x by 2 cos x minus sin x minus 3 by 2, 3 cos x by 2 or minus 3 cos. So, this is the particular integral for the given problem. Okay. So, option 3 is the right option. See, x by 2 cos x minus sin x minus 3 cos x by 2. Option 3 is the right option for this problem. Okay, we'll move on to the next problem. What is that? We need to find out the particular integral for the given function. We'll see. Pi equal to right hand side e power 2x cos 3x divided by f of d. F of d is nothing but given function d squared minus 4d plus 13. So, how to proceed the next? Whenever e power 2x will come, we should replace by d to d plus alpha in general, e power alpha x. Here what is given? E power 2x. In place of alpha 2 here. Okay, so we should replace d by d plus 2. Replace d by d plus 2. Okay. So, e power 2x na, that is. Now, we are going to replace d to d plus 2. D plus 2 the whole square minus 4 into d plus 2 plus 13. What is in the numerator? Cos 3x. Okay. E power 2x will be in the outside. Should be very careful in that. E power 2x will be in the outside. Cos 3x divided by, just expand this, d squared plus 4 plus 4d minus 4d minus 8 plus 13. So, plus 4d minus 4d get cancelled. So, then e power 2x cos 3x in the numerator divided by d squared plus, now eliminating the numerical, what is that? 13 plus 4, 17, 17 minus 8, 9. So, d squared 4 17 minus 8, 9. So, d squared plus 9 in the denominator. Okay. Now, whenever cos function come, what should we do? D squared equal to minus alpha squared. Here alpha equal to 3. So, minus 3 squared equal to minus 9. So, just substitute e power 2x cos 3x divided by minus 9 plus 9. So, what we will get? A numerator part divided by 0. It should not 0. It should not be absurd. It is absurd. Whenever denominator part is 0, we will get infinity. So, we should not get infinity. It is absurd. So, we should do one substitution. What is that? Multiply by x in numerator and differentiate denominator. Multiply by x in numerator and differentiate denominator in that function e power 2x. So, multiply by x, what we will get? X e power 2x cos 3x. Differentiate denominator 2d. 2d alone 9 we will get. It is a constant, we will get 0 only. So, 2d. So, what we need to do? So, x e power 2x by 2 will be in the outside. It is cos 3x by t, 1 by d differentiate integration. Okay, integration of cos 3x. So, what is the integration of cos 3x? Sin 3x by 3. So, now multiply x e power 2x sin 3x by 6. So this is the particular integral for the given problem. So x e power 2x sin 3x by 6, option 3 is the right option. Then we'll move on to the next problem. So pi, particular integral for the given function. What is that? Right hand side, x e power sin x divided by d squared minus 2d plus 1. So exponential function is given, so we take that exponential function outside. Whenever exponential function comes, we should replace by d plus alpha. So e power x here, so we are going to rearrange e power x into x sin x divided by d square d minus 1 the whole square. It is nothing but d minus 1 the whole square. So e power x comes, we should replace d by d plus alpha. So d by d plus 1. Replace d by d plus 1 in the denominator. So what we will get? D plus 1 minus 1 the whole square. Minus 1, this is minus 1 the whole square. So plus 1 minus 1 get cancelled. What we will get? E power x x sin x divided by d square. It is nothing but integrating 2 times, twice the integration. Okay, in denominator d squared is there, so we should integrate 2 times. Okay, we should integrate x sin x by 2 times. We are going to integrate now. We'll see how to integrate. So e power x x sin x divided by d into d. D into d is nothing but integrating that 2 times. Okay, what we will get? So it is integral u dv. U dv, we know that this is a basic integration. uv minus integral v du. So what is integral sin x dx? Here integral x sin x dx. So we'll integrate this. U is nothing but x. Integral dv is nothing but sin x dx. So integration x sin x dx. What is u here? From this u equal to x, dv equal to sin x dx. So what is du? Du equal to dx. Then what is v? To find out v, we should integrate now. So v equal to integrating sin x, what we will get? Minus cos x. So just substitute in the above formula, uv minus integral v du. So x u dv equal to uv. U is x minus x cos x uv minus integral v is minus cos x into du. D nothing but dx. Okay, just we are substituting that formula here. Minus x cos x minus x cos x. Whenever integrating cos x, we will get sin x. Already 1 minus into minus, we will get positive sign. Negative into negative, positive. Okay, for x sin x, we have integrated that for 1 time. For x sin x, we need to minus e power x into minus x cos x. Just substitute pa. Minus x cos x plus sin x divided by d. We need to integrate this part again 1 more time. Okay, so integrating sin x is a simple one. It is in addition. So we need to integrate minus x cos x. For minus x cos x, we should follow the above procedure like uv minus integral v du format. The same thing. Minus. So we will take only x cos x. Negative sign, let it be there. U equal to x here. Du equal to dx. So dv, what is that here? Cos x dx. Du equal to dx. What is v? Integrating that, we will get v equal to sin x. Okay, just substitute in that formula. Integral u dv equal to uv minus integral v du. So u equal to x into sin x, uv, x into sin x minus integration v sin x du is nothing but dx. So now x sin x when we integrate sin x, we will get minus cos x. Already or minus sign is there, so plus cos x. So for x cos x, we have derived this. Okay, clear? For x cos x, we have derived x sin x plus cos x. Negative sign, we should include the negative sign. Pa equal to e power x minus, include that minus sign, minus x sin x minus cos x. Then we should integrate, we have integrated this part, then integrating plus sin x by d already there now. So whenever integrating that, what we will get? Sin x minus cos x. Minus cos x we will get. Okay, so this is, take minus sign outside, minus e power x, it is e power x only, I am right, minus cos x plus 2 cos x. Okay, the minus sign will be in the PA. Okay, PA equal to minus e power x, so it is e power plus x only, not minus x, minus e power x, option 1, minus e power x, x sin x plus 2 cos x is the right option. Then we need to find out the next problem. What is the solution of the given function? See, this is the solution of variable differential coefficient. So we can x squared into d squared, y double dash is nothing but d squared minus x into d plus 1 into y. Here 1 is a constant, no, plus 1 into y should be in the outside, equal to x squared. We should do some substitutions in this method. See, let x equal to e power z, then what is z? Z equal to log x. Then what is xd? Xd equal to theta. X squared d squared equal to theta into theta minus 1. Then xd equal to theta. D is nothing but capital D by dx. What is theta? Theta equal to d by dz. I have taken here as a d by dz as theta. We can take it as anything. In some other author will give d dash also. To avoid confusion between d and d dash, I have taken as theta. So just substitute in that formula. What is x squared is square theta into theta minus 1 minus xd is equal to theta plus 1 into y. What is x squared? X squared, x equal to e power z now. So e power z the whole square. Theta squared multiply inside minus theta plus 1 into 1 e power 2z. E power z the whole square nothing but e power 2z. So e power minus 2 theta plus 1 into y e power 2z. So we have reformed this differential equation with z, theta and dz. Now we are going to follow the same procedure like other differential equations. So to find out complementary function, we assume RHS equal to 0. Then what is the next step? To find out auxiliary equation. Auxiliary equation is nothing but replace theta by m squared minus 2m plus 1 equal to 0. So m minus 1 the whole squared equal to 0. We have two roots for m, that is 1 comma 1. Okay, if it is root c, we have two roots for m. Roots are real and equal roots. For real and equal roots, what is the complementary function? A plus bz here with respect to z only. So I am writing x, it is not x, a plus bz into e power x z. So now we should change with respect to x. We know that z equal to what? Z equal to log x. Okay, a plus b log x into e power log x. So exponential and logarithmic can cancel. What is the complementary function? A plus b log x into x. Okay, so complementary function, say it is a equation 1. Then we need to find out what? The particular integral. Okay, because solution y clubs the both particular and integral and complementary function as well. So for particular integral we should use the RHS. So RHS is of type e power 2z divided by f of d. F of d is nothing but theta squared minus 2 theta plus 1. So theta squared minus 2 theta plus 1. So whenever exponential comes, what we should replace? Theta equal to 2. In place of theta, we should replace by 2. Theta equal to 2. Then e power 2z divided by theta squared. 4 minus 4 plus 1. So 4 and 4 get cancelled. So e power 2z alone. Particular integral e power 2z. Now substitute z equal to log x. We should replace, don't forget this, we should change as a function of x. Okay. So e power 2 log x. We know the logarithmic formula, right? Log a power b log a. So 2 will go the power of x as x squared. Okay, e power log x squared. So exponential and logarithmic get cancelled. So we will get pi equal to x squared. So it is the equation 2. Then the solution y equal to adding equation 1 and 2, complementary function and particular integral. So a plus b log x into x into x plus x squared. So y equal to, the solution of differential equation is nothing but option A. For this type, we will see some problems in this type. Okay, for variable coefficients, how to solve this. Okay, we should remember that substitutions. Okay, so solution of that function we are going to find out. So x squared y double dash we can replace at d squared. So x squared d squared minus x d for y dash plus 1. We are going to take y outside. Okay, log x plus pi. So now what is that? X equal to e power z. Let x equal to e power z. Then what is z? Equal to log x. So x equal to z equal to log x. Let x equal to e power z. Then x squared xt equal to theta. X squared d squared equal to theta into theta minus 1. D equal to d by x. What is theta? Theta equal to d by dz. So just substitute in that above equation. So theta into theta minus 1 minus theta plus 1 into y equal to, in place of log x substitute z, right? Log x equal to z plus pi. Theta squared multiply inside minus theta plus 1 into y equal to z plus pi. Theta squared minus 2 theta plus 1 into y equal to z plus pi. So this is the differential equation we have formed. Now we are going to find out the complementary function and particular integral using the procedure. We know that. Okay, complementary function, what should do? We should assume right hand side should equal to 0. Then auxiliary equation is nothing but replace theta by m square minus 2m plus 1, right hand side equal to 0 for complementary function. So this is nothing but m minus 1 the whole square. So we have m equal to 1 comma 1. We have two roots. Two roots are real and equal. So for equal and real and equal roots, what is the complementary function? A plus b z or a z plus b. Whatever it is, right only. So e power z. Because e power alpha is z. Here alpha is m equal to 1 only. E power m1x. E power mx, sorry. So here m is equal to 1 only. Two roots are equal. So a plus b z into e power z or a plus a z plus b into e power z. both are same only. According to the option we can rearrange. So a is z plus b. So now going to replace by with respect to x. So function of a log x, z equal to log x now plus b into e power log x. E power log x exponential and logarithmic get cancelled, we will get x only. So a log x, this one. So this is the complementary function, say it is the equation 1. Then what is the next step? We are going to find out the particular integral for the given differential equation. Particular integral, we should use the RHS. RHS equal to z plus pi divided by f of d, theta square minus 2 theta plus 1. Whenever z function come, we should replace by 1 minus theta form. We should rearrange by 1 minus theta form. So we'll see how to do that. Pi is a constant, so let it be theta minus 1 the whole square. We can write like this, yes, theta minus 1 the whole squared. So we should replace by 1 minus z format, 1 minus theta format. So whenever taking 1 minus theta minus 1 the whole will go to the numerator as theta minus 1 whole power minus 2, okay, or 1 minus theta. I said already no, z plus pi divided by 1 minus theta, minus will be in the outside, 1 minus theta the whole square. So negative square we will get positive sign only. So 1 minus theta the whole square will go to the numerator as 1 minus theta whole power minus 2. This is of the form of 1 minus x whole power minus 2. For that we have expanded series. What is that? We'll see 1 minus x whole or 1 minus x or 1 minus z, here function of z. So whatever may be 1 minus z whole power minus 2. What is the expansion of that series? We'll see 1 minus z, for that 1 minus theta whole power minus 2. So 1 minus z whole power minus 2 is nothing but expansion 1 plus 2z plus 3z square. There is no other way, we should mug up this, okay. This is the expanded series. So here in place of z we have theta. So 1 plus 2z plus 3z square. Just substitute this here, the expanded series. We no need to expand the whole thing. We should stop up to the order 2. Okay. No need higher order powers. Up to order 2 is enough to solve this problem. Okay. Then substitute 1 plus 2 theta plus 3 theta squared. Is it enough? Okay. So just multiply inside. 1 into z plus pi, we have z plus pi, then 2 into theta is nothing but d by dz. So 2 into d by dz of z, what we will get? 1 only. So 2 into 1, 2 only. So we'll see 2 theta into z plus pi, what we will get? Theta equal to d by dz na, 2 into d by z. So dz by dz we will get 1 only. So 2 into 1. Whenever differentiating constant pi, we will get 0, we will get 2 only. So for differentiating one time, we are getting 2 as a constant. For 3 theta squared, I am saying 3 theta squared is nothing but d squared z by dz squared. So again differentiating the 2, we will get 0 only. For pi already we are getting 0. It is a constant. So again differentiating the 2, we will get 0. So it is enough. It is over. So z plus pi plus 2 equal to, that is the particular integral. Differentiating one time itself we are getting the constant 2. Again differentiating we will get 0 only. So higher order power we will get obviously as 0 only. So z plus pi by 2 plus pi by plus 2. So what is the solution? Y equal to cf plus pi, clubbing the adding equation 1 and 2. So a log x b plus b into x plus particular integral z plus pi plus 2. Okay, so this is the solution of this differential equation option 3, a log x plus b into x plus log x plus pi 2. Okay. So z we have substituted as log x. So then next problem, solution of differential x d square plus d into y equal to 0. So it should will multiply by x in that equation. What we will get? X squared d squared plus xd y equal to 0. Now we are going to do substitutions. What is that? Let x equal to, so right hand side is 0. So we have only complementary function. There is no particular integral for this differential equation. So finding out complementary function is more than enough for this problem. So x equal to, let x equal to, so xd equal to theta, x squared d squared equal to theta into theta minus 1, z equal to log x, then x equal to e power z. Just substitute all this in that equation. So d equal to d by dx, where theta equal to d by dz. Okay, theta into theta minus 1 plus theta into y equal to 0. So theta square minus theta plus theta into y equal to 0, minus theta plus theta get cancelled. So theta squared y equal to 0. So we are going to find out the complementary function. So m equal to 0 comma 0. So it is roots are real and equal. So e power 0x az plus b. When this is the complementary function and solution as well. So e power alpha x, 0x is nothing but 1 only. So az plus b, y equal to az plus b. We are getting, in place of z substitute log x. So what is the solution? Y equal to a log x plus b. That is e power 0x, we will get 1 only. Y equal to a z plus b, substitute z equal to log x, y equal to a log x plus b. Option 3 is the right option for this problem. Then move on to the next problem. Solution of the given differential equation. So these are all the example problems for the variable differential coefficient. So we should do all the substitution and then proceed the normal differential equation type. So divide by x. Whenever we are dividing by x, 3x d plus 5 into y divided by 2x. We are going to divide by x. So now x, let x equal to ez, then z equal to log x. Then what is xt? Equal to theta, x squared d squared equal to theta into theta minus 1. Okay, I'll substitute all this. Xd equal to theta, 3 theta plus 5 into y to find out complementary function. So sorry, 2 by e power z in place of x, 3 theta plus 5 into y, 2 into e power minus z. This is the reformed differential equation of variable coefficient. Now we are going to find out the complementary function. For that, assume RHS equal to 0. Right answer should be 0. Then theta, replace theta by m. So 3m plus 5 equal to 0. 3. Okay. Right hand side equal to 0. Then we should find out the root for m value. M value, what is that? Theta equal to m. Replacing theta by m. 3m equal to minus 5. What is m then? M equal to minus 5 by 3. So we have find out the roots. So what is the complementary function? C equal to some constant. Complementary function CF equal to a e power minus 5z by 3. 5z by 3. So now we are going to replace by z a e power, in general a e power alpha x or a e power mx. Here m is nothing but minus 5 by 3. Okay, a is a constant, because why I write a in the options given as a, so we are representing constant as a here. So in place of z we are going to substitute by log x. Okay, z equal to log x na, we'll do substitution. A e power minus 5 log x, so log x power 5 by 3. Okay, this is like log a power b formula, b log a. So e power minus sign go to that 5 by 3 power minus 1. Exponential and logarithmic get cancelled. We are getting CF AX power minus 5 by 3. Okay, E and exponential get cancelled. So x power minus 5 by 3. Because whenever we substituting z equal to log x, exponential and log term get cancelled. Then before getting cancelled, so log x 5 by 3 na, so that will go to log a power b. Here a is log ab, log a power b we can write it as 5 log a. Okay, complementary function equal to a, basic logarithmic formula guys, log a power b, b log a, in that x power minus 5 by 3. Okay, now particular integral 2 e power minus z by 3 theta plus 5. Now what we need to do, substitute theta by minus 1. Okay, in that equation. So 2 e power minus z minus 3 plus 5. We are getting 2 e power minus z by 2. 2 and 2 get cancelled, e power minus z. So z substitute log x, e power minus log x. So it is also minus b log a power b. We are getting logarithmic function log a by b log a, right? So here b is minus sign, so log x power minus 1, that is 1 by x. So y equal to complementary function plus particular integral combining 1 and 2 equation. So a x power minus 5 by 3 plus 1 by x. This is the solution for the given differential equation. See which one? Option 3, y equal to a x power minus 5 by 3 plus 1 by x. Then we'll move on to the next problem. So we are going to do conversion of x squared d squared given function into an equation with constant coefficient. We are not going to solve for the solution of differential equation in this formula. We just going to convert the differential equation with the constant coefficient. We'll see, we know all substitution, right? X squared d squared, just write down the problem, a plus xd plus 7 into y equal to 2x power minus 1. So x squared d squared equal to theta, x equal to e power z, then z equal to log x, xd equal to theta, x squared d squared equal to theta into theta minus 1. So substitute all this, where theta equal to d by dz, capital D equal to d by dx. So substitute all this in that equation. Okay, x squared d squared theta into theta minus 1 plus xd equal to theta plus 7 into y, then 2x power minus x equal to e power z, e power minus z. Okay, now theta squared minus theta plus 7 into y equal to 2 e power minus z. So minus theta plus theta. We are going to just convert this equation. Get cancelled, then theta squared plus 7 into y equal to 2e power minus z. So theta we know that d squared is y by d z squared plus 7y, or 7 plus 7 into common y, 2e power minus z. So this is the conversion. Option 4 is the right option. D squared y by d z squared plus 7 into y equal to 2e power minus z. Now we are moving to, this is the final problem in this video. So we are going to eliminate the constant x from, we are going to eliminating the x, not eliminating x from that given equation. What is given? So dx by dt plus 2y equal to 0, then equation 1, then dy by dt minus 2x equal to 0. So from equation 2, what is x? We are going to eliminate the x only now. So dy by dt equal to 2x from equation 2. Then what is x? 1 by 2 into dy by dt. Just substitute in that equation 1. X value, substituting x value in that equation. So d by dt in place of x, 1 by 2 dy by dt plus 2y equal to 0. So d squared y by constant outside, half d squared y by dt squared plus 2y equal to 0. Then cross multiply, what we will get? D squared y by dt squared plus 4y equal to 0. So this is the answer. Option 1, d squared y by dt squared plus 4y equal to 0. We are eliminating x from the given equation. So this is the final equation. So kindly subscribe our channel Off Campus and then click on the bell icon. You will receive notification as in when we upload videos. So kindly stay tuned to our channel. We have posted many videos under engineering mathematics and electronics and communication. So if you haven't seen those videos still, kindly check with the playlist. Okay, we have posted almost 200 problems in the differential equation only. In our upcoming videos we are going to post and solve many problems. So kindly stay tuned to our channel. Thank you.